Hey guys, this is Mike, and this is part 5 of the Connect Me development. So I did update the graphics a little bit. So I have this looking thing now. I changed the grid. Instead of the wooden stuff, I'm just going to go with some abstracty looking thing. And the cells look a little bit better. I don't know if I'm going to keep this yet, so again, this is possibly temporary. Not sure. Also, I'm adding the 1 pixel image to my pack because the pixel is awesome. If I need anything, like I'm gonna use it here to set the checkered pattern. I can't like set the checkered pattern in the image because it can be of random size. It's 5x5 and 3x3, so I need to do it programmatically. So I'm gonna use my 1 pixel image for that. Pack and pack all of it. There it is. And just stick that into the assets here. Yes to all. So if I run it now, and I have couldn't load file pixel.png. Right, I just took off the pixel image. Where is that coming from? Here, I don't need this. Text. Right, okay. So if I run it now, you can see updated graphics, sort of, and you can see it looks slightly jaggy around the edges. That's because the default filter is nearest neighbor, so it just grabs whatever the nearest neighbor color is, and that's what it is whenever you scale it. So that's not good. So I'm gonna go over here and change the atlas texture, get textures that I should just go over all of them. There can only be one, right? Let me see. What is there a list? The size. Size is one. There's only one texture. Not sure what's going on. So atlas dot get textures dot first. Okay, I don't have to use an iterator. Set filter texture filter dot linear for both of them. Filter dot linear. One's for minimum and magnet or something, I think. And that should make it look smoother, no more jaggies, because it takes average data from the surrounding pixels for scaling. So the next thing I want to do is the checkered pattern, and I'm going to do that using the pixel that I made. So that's part of the grid, I think. I'm just going to go in here. I need the pixel image. Private texture region pixel. And I'm just going to copy and paste this here. Pixel. Okay, so that we have pixel here, and we're going to be drawing the pixels after, but we want it to be drawn with an alpha. We want to set the color to black first. Color.black. Oh wait, no, not exactly black. Because we want it with an alpha, so color checkered color is equal to black, but maybe a quarter alpha. So I'm gonna set that here, checkered color, and I'm going to have to draw. Oh wait, I have to put it in the for loop. So checkered pattern goes alternating, odd even, odd even. If row plus column is even, then I will draw the checkered color. sb.draw pixel at what position? Row, or no, x is column times cell size. No, x plus. I have to remember about the grid position as well. Row times cell size. Let's see. That's obviously not working. Because I'm not setting the pixel size, cell size. Cell size. There we go. Oh, it has the padding. Cell size has padding off of it. No, it doesn't. Cell size is size minus num calls. So what? Why is... Oh, right. Because I put a padding on the outer edge as well. And why is it only this bottom row? What's going on there? Row plus column mod 2 0. Why did it stop at the bottom? There. This not print line. Row plus column. What's going on here? 0 and 2 only. Why? Row plus... Oh! Order of operations probably, right? There we go. So that looks pretty cool. Wow, the speed could be a little fast. Let's slow it down. 1,000 pixels per second. It's probably just lagging because of the recording, but I think 1,000 is good. Are these... Is the black messing with the shade of the cell? Because I'm drawing it before I'm drawing the cell, so why is it affecting? Let me double check. Let's make this 95. Yeah. Why are some of the cells drawing after the thing? Oh, right, because I'm drawing Y inverted. Okay, so this is num rows minus row minus 1. And the order I'm drawing it. There we go. So back to quarter alpha. Yep, that looks cool. I still have to do something about this outer border over here. That's... Maybe I can get rid of that outer border. I don't need it. We'll see. I will try to get rid of it. X column... Where is it? Minus cell padding. This. I'm going to get rid of this. And plus this. I'm just going to draw straight up. Yeah, that looks pretty good. I don't need the extra padding on the outer edge. Let's try with 3x3. Okay, I'm gonna run this so I can have something to compare to. Let's try 3x3. Okay. Ooh, nice. So the diamonds do scale, or the cells do scale up, and they look decently scaled. No jaggies, thanks to the linear filter. And let's try a 5x5. 1, 0, 2, 0, 1, 0, 2, 2, 1. Let's see what that looks like. Comparison. 5 by 5, nice. So we got 3. What in the hell? 3, 4, 5. It looks pretty good. Okay, so another thing that I really want to stress is whenever I have event-based animations like this where I'm swapping, just so I can exaggerate what it looks like, I'm going to slow this down to maybe 50 pixels per second. So when I swap, see what's happening there? Okay, let me slow it down even more. When I swap the positions immediately. Like immediately, if I swap these two, this one becomes the green cell, and this one becomes the red cell. At least on the back end, logically, that's the first thing I do. But their position hasn't reached the other side yet. So if I swap here as well, you'll notice it. Ooh, I mean, it's sort of messed up. So what I'm going to do is to disable any kind of moves until the animation has finished. So I can't just go swapping random stuff like this. Look how, oh. Even though I'm gonna make the speed at 1000 and it's highly unlikely that you can swap two like so quickly, it's still something that I want to do, just to show you. I don't think I've ever done any listener patterns in any of my videos, so it's a good time to start here. So what I'm going to be making is an actual listener for the first time. Let's see. So in the video, I'm going to make something called an animation listener. Basically, it has to be an interface. So a listener pattern is pretty simple. You use it to sort of decouple classes, so that in general other classes can use them, and you can use them as callbacks. So on animation listener, I'm going to have unstarted and unfinished. So these two methods have to be overridden for any class that's going to use them. For example, grid is going to be implementing it. Implements animation listener, my animation listener. So you can see here it's underlined because I have to override the two methods. So I'm going to put the animation listener stuff down here. Just override both of them on started and on finished. And what I'm going to do is I have to wait until all of the animations have finished. Namely, whenever I swap two things are being animated. So again, I'm going to slow it down to 10 pixels per second. And you can see I'm going to try to prevent that. And I'm going to do that by creating an animation count. Animation count. Whenever an animation starts, I'm going to increase the count by 1. Whenever an animation finishes, I'm going to decrease it by 1. And I can only move if the animation count is 0. So back in my move method here, if animation count is equal to 0 or greater than 0, return. I don't want to do any moves. So the way we do this is to basically give each cell a listener. Public void set listener, animation listener. This listener is a listener, so I'm gonna give this its own animation listener over here. Cool. So now I also have to give the grid, which is an animation listener to all the cells when I create them. So cell.set animation set listener this. So now the cell has a reference to grid as an animation listener, and it can call these two methods. So whenever a cell starts animation, which is this set destination, I'm going to do listener. If they're always going to have listeners, so I don't have to check for null. Listener dot on started, and that's it. And when this animation finishes, like over here, if x dest is equal to x and makes more sense the other way. If x is equal to x dest and y is equal to y dest, then I'm finished with the animation, and I should do listener.onFinished. And that's it. Let's see if I can't move while the animation is still happening. Cool. So you can see I cannot move until this is finished. It's finished. And then I can move another one. Nice. So that's pretty much it for listeners. I should probably use listeners a lot more, and I know I haven't used it in my previous tutorials or videos even, but they're pretty useful. So for example, I can make a finished listener for the grid, or grid listener for play state when the grid is finished, and then it just calls back something in play state. But that's something for later. Let's see, what else was I gonna do? Oh right, I totally forgot about the checkered. Wait, did I do the checkered pattern? I did. Oh my god, I didn't even remember. Is that too dark? I have it more subtle over here. It looks too dark. I'm gonna make it more subtle. Gonna set the color to something lighter. Quarter, too much. 1/5. 1/10. Oops. This one. Yeah, subtle enough. That looks exactly the same shade, actually. Cool. Cool. Oh wait, I have to put the speed back. Where am I? What am I doing? Over here, cell, speed, back to 1000. Right. So, yeah. This is a 5x5, so this is going to be ridiculously difficult. I mean, to find the minimum number of moves, so I have to restart a system, or force our system. I don't know if that's such a good idea. This is insanely difficult. I finished it in 31 moves, but this is like that thing with God's algorithm for Rubik's Cubes, how they figured out that like the minimum number of moves, the most number of moves, wait, what was it? The maximum number of moves, or the least number of moves to get to the, no. I don't know, but something about the minimum or maximum number of moves to finish a Rubik's Cube from any position being like 20 or something. You can always finish a Rubik's Cube in 20 moves. Something like that. Let's see here. And they don't have the manpower or computing power to actually test that out, because the Rubik's Cube has like the 1 something quadrillion, something quintillion, I don't even know how many different permutations. So same thing with this. I can't exactly, if I try to brute force this is a 5x5, it's probably going to take hours, maybe, to figure this out. Like, to have the algorithm find the minimum number of moves, it's probably going to take hours, because the number of permutations increases dramatically with each row column added. So for this video, oh, right. What happens when, I should fix the size issue. What happens when it's 5x4 or 4x5? I got that extra row up here, so I'm gonna fix that right here. Might as well. So instead of size, I'm gonna do width, and oh, I should probably rename this to width. No, I'm not gonna refactor it because I want to know everywhere where it's not right. Height. Yeah, so I should set height after getting the cell size. Cell dot size is equal to width divided by number of columns, x padding. So height is equal to cell dot size, no, number of rows times cell dot size plus padding times 2. No. It's just this. Yeah, whatever. It's just that. Y is cm dot height minus. Oh, this is gonna be height now, not width. Down here, it's gonna be width and height. Cool. That should. Nice. Oh man, that is nice. So that's 5 by 4. If I go smaller, 3 by 4. Oops, 1. There we go. So rescale is automatically. That's cool. I'll just bring it back down to 3 by 3. Nice. This is freaking awesome. Oh, and it looks much nicer. This is better, way better design than the other one. Again, I'm gonna keep working on the graphics just to make it look even better. Again, I'm not sure if I'm keeping this cell design, this diamond stuff, but for now it looks pretty cool. That is probably going to be it. Let me just push these. What exactly do we do? Cell? Oh right, listener? Animation listener, I mean. Oh, what? Insert animation listener. Grid. Alright. Grid size. Animation listener. Content. Right. New linear filter graphics. That's pretty much it. There you go. So that's going to be it for this video. Not sure what the next one's going to be, so yeah, we'll see. Thanks for watching. Hey guys, this is Mike. So part 5, pretty much an addition here. Right after I made that video, I just realized that on finished is wrong because this gets called 60 times per second, which is not good. So animation count goes way below. I don't even know why. Where is it? Why it's still working? Because animation count is less than 0. Oh, right. So you can still do the movement thing, but the thing where you can move more than one at a time without having to wait. So I'm gonna have to fix that here. I can't do it over here. I have to do it once when the thing is finished. So if X is finished, if Y is equal to Y dash, then I know it's finished. And I'm only going to do it once. Same thing with the Y. X test. listener.onfinished. Hopefully now it doesn't get called onfinished every single time. Onfinished. See, called onfinished twice only. That's good, because 2 of them are finished. Oh, that was an issue there, or it could have been an issue. So yeah, that was just a small fix. Thanks for watching.